Hello, my name is METİN. This is 264th part of explanation of my theory. According to my theory and my formulas, why can't attosecond physics be successful with the foundation it is based on? Tonight, I will talk about the different movement abilities of each electron in atoms. Why are the spectral lines of each atom unique? If all electrons in atoms had the same characteristics, would these specific spectral lines occur? No. The reason for the formation of different characteristic spectral lines specific to each atom is that the electrons in each atom have different wavelengths. Each different characteristic spectral lines of different atoms produced by dominant specific wavelength-sized electrons. As a result of the calculations I made according to my theory and my formulas, I discerned that the electron with the smallest wavelength is the most dominant electron that produces most of the characteristic spectral lines specific to an atom. According to my calculations, of course, some electrons with different wavelengths were also producing some of the spectral lines. As I formulated and showed before, according to me, proton-bound electron motion forms were affected by free electron motion forms successive waves. The wave affected the proton-bound electron and expanded it up to n squared multiplied by lambda e with speed of light. The wave affected the proton-bound electron and expanded it up to this quantity. For instance, third wave, third free electrons, third successive wave, like this, like this, like this. Here a proton, here a proton-bound electron motion form. Here free electron motion form that produces and propagates successive waves. First, second, third, just now, fourth, n is equal to 4, and this direction, this direction, this direction, this direction, like this. Okay, what was the formula? When coincide with joint motion axis of proton and proton-bound electron, say for instance fourth wave of this free electron motion form affect this proton bound electron motion form 4 squared multiplied by what was that proton bounds at rest initial wavelength, say 0.17 nanometer, okay, up to 16 multiplied by 0.17 nanometer. Here, from n is equal 1 to n is equal 4, nanometer, okay, from what? 0.17, from 0.17 to 2.75 minus 0.17, okay, difference 2.55 nanometer, okay. Yes, for instance, up to 2.72, up to, as I formulated, n squared multiplied by lambda initial, okay. This is my formula. What is one of my formulas? Okay. Again, as I formulated and showed before, according to me, proton-bound electron motion forms were affected by free electron motion forms successive waves. The wave affected the proton-bound electron and expanded it up to this quantity with speed of light, c, okay. For instance, again, this is initial state of electron motion form, but when, say, fourth successive wave affected this, it enlarges, it expands at the speed of light, okay, speed of light. And when this effect vanish, it shrinks again at the speed of light. We can calculate all of these. We can calculate zeptoseconds, attoseconds, etc. Okay? There's no uncertainty principle. Uncertainty principle, Heisenberg principle, is invalid, as I told you before, as I showed you before. Okay. Yes. Here, n is effective waves number, lambda is line producer proton-bound electrons specific wavelength. According to me, all different sized electrons in an atom, if they are not disturbed by successive waves or adiabatic change, say all of they at their ground states, if they are not disturbed, they were at rest, they were not relocating, they were not expanding or shrinking, so we can know their place absolutely. Okay? And when we affect them we will be able to know when and where they will be. But as long as the electron is assumed to be a point particle, an object of probability waves, a dimensionless point, an uncertainty object, as long as the electron is assumed like this, correct results will not emerge in physics. Left side, my calculation according to my theory and my formulas. Right side, National Institute and Standards, National Institute of Standards and Technologies data. Right side, left side, my calculations. Again, snapshot. As I have told you before, first page. This was sodium. Here, nitrogen. Left side, my calculation. Right side, NIST data. Here, blue square, initial wavelength, sixth wavelength of nitrogen, 2.24 nanometer, red square, seventh electron of nitrogen, dominant. First one was dominant. Two dominant electrons have different wavelengths. Red square, seventh electron, 1.85. Okay, and here, according to my theory and my formulas, I have calculated, and yes, here, left side my results, right side, observation, proofs, observation, measurement, experiment, theory left side that I put forth, experiment here. Okay, line by line, you can check. Then, here, wait a moment. This is neon. Neon atom, multi-electron atom. Okay. Left side my calculations, right side NIST data. Yes. Here. Everything is certain. Everything is precise. Sodium again. Yes, snapshot. Yes. Yes. Yes. And here. Yes. I will go on next. Have a good night. See you later.